So letter D, we have to find the area of an equilateral triangle. And on its face, this looks like it's going to be pretty easy. But actually, um, it's really easy to do this in a hexagon. It's not quite as easy in an equilateral triangle. So let's see if we can figure this out. And I'm just going to take another right triangle shape. And let's see. So this is my apothem. Remember, the apothem is equidistant from each of the vertices. So what I'm going to do is I'm going to draw a little right triangle here that has one side that is the distance between the center and this corner vertex here. Okay, so this is the triangle we're going to be looking at. Now, I just want you to think about what I just did. I took a line from the center to the vertex, which bisected the vertex angle. This angle here is 60 degrees in equilateral triangle, but I bisected it, so that means that in my little right triangle I just made, this angle is 30 degrees. And it's a right triangle, so that means that this angle over here is 90 degrees. Wait, is this a 30, 60, 90 triangle? It sure is. And do I know any of the lengths of this triangle? Well, I know that the bottom of this triangle, which came from this right here, has to be half the length of one of the sides. So once again, this is going to be 6 meters here. Oh, but this is the hard side to know because on this hypotenuse side, I'm going to have like some weird square root relationship, right? Because it's a 1, 2 square root of 3 triangle. And also on my leg side, I'm going to have another, because this should be whatever this side is times the square root of 3. So how am I going to figure out what this side is? Well, let's just think about that for a second. Let's say that this side has length A because it's the apothem. That means that A times the square root of 3, okay, so I'm going to bring down A, and we'll grab our square root of 3 term from up here. A times the square root of 3 equals 6. Does that make sense? In a 30, 60, 90 triangle, if you multiply the short side by the square root of 3, you get the other leg, okay? Or we could divide both sides of this by the square root of 3. And if I divide both sides by the square root of 3, I get A on a side by itself. So the apothem is 6 times the square root of, or 6 divided by the square root of 3. That's good enough. That's what I need to be able to solve this. I just need to know the length of the apothem. So what am I going to do to solve this? I'm going to use my formula. 1/2 times the apothem, which in this case is going to be 6 over the square root of 3, times the perimeter. And the perimeter of this is 36. I can just do that in my head as I add all 3 sides. Okay, 1/2, 6 over the square root of 3 times 36. That's going to be, well, 1/2 of 6 is 3. 3 times 36 is 90 plus 18, 108. So this is going to be 108 over the square root of 3. But I can't have a square root in my denominator. So I'm going to multiply this fraction by the square root of 3 over the square root of 3. That's going to give me 108 times the square root of 3 over, and this whole thing divided by 3. Okay. And I could actually do 108 divided by 3. Off the top of my head, I'm just going to use a calculator to figure that out. 108 divided by 3, 36. So in its simplified form, this just becomes 36 times the square root of 3. End of story. All right, let's just make sure we did that right. Now remember, in order to do that, I had to figure out what the apothem length was for a triangle like this, and I had to use a little tiny right triangle here. It was a 30, 60, 90 triangle, and then 30, 60, 90 relationships to figure that out. And we did that correctly. We just needed to say that it's in meters squared. Also, I just noticed we forgot to put feet squared for letter C. All right, and then on to letter E. The shape of a playground is a regular hexagon. Well, that's setting off some alarm bells. I know I'm going to be able to deal with hexagon inner angles as 60 degrees, where each side length is 78 feet long. The playground is to be resurfaced with a non-slip rubber material. What is the total area to be resurfaced? Well, this is going to be the same as this problem was basically, except instead of, let's see, instead of each side being 12, each side is going to be 78. Half of 78 is, what is it, 39? And it's 39 feet. So that means this is going to be 39 feet. This is going to be 78 feet, okay? And then this down here is going to be 39 times the square root of 3 feet. So what am I going to do on this one? Well, the apothem for a hexagon like this is going to be this side. So it's going to be 1/2 times the apothem, 39 square root of 3, times the perimeter, which is going to be 78 times 6. Once again, there's no way I'm doing this without a calculator. 1/2 times 39 times 78 times 6. 1/2 times 39 times 78 times 6. That gives me 9,126. So the answer is going to be 9,126 times the square root of 3. Let's see if they kept it in, yep, they kept it in simplified radical form. So I'm just going to write out the answer here, and we are done. 9,126 square root of 3 square feet. All right. So some of these aren't quite so easy, but you can do all of these for next time. Make sure you're focusing on whether it's a hexagon, whether you're dealing with equilateral triangles, and then finding the apothem from those if you need to.